So I want to generalize the idea of decision tree and then make it into a random forest. And just by the name, forest means that you are going to do the decision tree several times. So in fact, random forest algorithm is a sequence of actions. It's combining something called a back-in. I will explain that later. But in the middle, it is the decision tree. And actually, I want to say it is decision trees. You have several trees. So you can imagine that each of the tree is like a judgment. Okay. Now a new data come in. First tree tell you that it is category 1. Second tree says that it is category 3, and so on. So each tree will tell you one of the possible label. So in the end, you have to use the voting system, use the majority rule to tell, okay, most of the community member in all these trees is thinking that it belongs to a certain category, then it votes to something. Okay, and so first, let's talk about back-in. Back-in is a very simple idea. Remember, we have the data called X. It has n samples and it has d features. And the idea of back-in is I'm not going to use all the samples. I'm not going to use all the features. I just want to take some of them. Okay. So back-in means use only some samples and some features. And how do we choose them? We choose them randomly. Okay, so for example, I'm going to just pick the like a 60% of the sample, and I'm going to take also 60% of the feature. I'm going to call this as X prime. All right, so from the bigger data, then I just take a small proportion of the data, and then I take the new data, and then I send this smaller data into the decision tree to create the one tree. I just build one tree by sum of the data. So the next time you are going to do the back-in again, you take some of the sample, some of the features randomly. So the next time it might be the other part of the sample, the other part of the feature, and then you send that to decision tree. And then you build the second tree. So basically you have a lot of different samples and features. So sample 1, sample set, number 1, feature set, number 1, and you do this several times, and then it gives you tree number 1. And then you have a sample set number 2, and then feature set number 2, and then it will give you tree number 2. So now if a new data point comes in, then the first system will give you a prediction. And this prediction will give you a vote. It votes that, okay, this data point belong to a certain category. It thinks the tree number 1 thinks that, okay, it is belong to label 1, for example. And the tree number 2 will give you the second vote. And in the end, you collect a lot of votes according to the majority rule. 多数决. Okay, and you got the majority rule, then okay, it is a certain label. So this system is very simple, and it turns out that it is quite efficient because it avoid to be overfitting, because you are going to take only partial part of the label, a part of the samples and part of the features, and you can extract the information from there. And because we are going to do a lot of trees, each of the tree are coming up randomly, so it's called random forest. Now the last thing I want to say is this kind of model does not really rely on the decision tree. Okay, so for example, in the previous case, what did we do? In the last week, we do K and N, the nearest neighbors, right? So for example, we can replace this tree by one of the KNN model, right? We do the bagging and then send that to the KNN model and then get the vote. And maybe the other, I can replace that with a different classification problem. So I can use several classification models, and then collectively we got the label. And really, this is like how human making a decision, and that's why it's always not good, right? So basically, if we want to make a decision, we will form a committee, right? 就是委员会, okay? We will have a committee, and this committee has several members, and each member is representing certain expert. It is the expert in certain field. Okay, so the first one, it is the expert in distance. So it is KNN, for example. The second one, it really like the tree structure, it is the decision tree. And the third one is another one, maybe the neural network. So you will get the different features, but really they are from different backgrounds, but they can cooperate with each other simply by voting. Well, voting is not really the best system, but it is efficient, and you get a conclusion, and well, somehow most of people will accept that, right? So eventually you use the majority rule to get this prediction. And such an idea is called ensemble learning. Okay, and ensemble means that collectively everybody is providing some idea, and collectively we are making the decision. So this kind of idea does not really just apply to decision tree random forest. It also applies to other cases. Basically, you can use several models and then make a decision in the end.